Derivative of inverse trigonometric function. The inverse trigonometric function, we call this arcsine. So for trigonometric function, we have sine, cosine, tangent, cosecant, secant, and cotangent. So for the inverse trigonometric function, we have to add the word arc, arc, in front of the trig function. So for arcsine, the derivative of that is 1 divided by the square root of 1 minus x squared. The derivative of arc cosine is similar to sine, except the top is -1. So I have to make a note. The arc cosine is the same as cosine inverse of x. So either you write arc or you write the -1. So the -1 means inverse. It is not an exponent. So inverse cosine of x is the same as arc cosine of x. You study that in trigonometry. The derivative of arctangent x is 1 divided by 1 plus x squared. So for arc cosecant and the arc secant, these two derivatives, they are less popular compared to the other four. So for arc cosecant, you have -1 divided by absolute value of x times the square root of x squared minus 1. And then for the arc secant, you remove the -1, you change the -1 to a +1. And then for arc cotangent, compared to arctangent, you change the +1 to a -1. So let's do a couple examples regarding derivative of inverse trigonometric function. The first example, let's do a y equals to arcsine. Inside the parenthesis, I would like to do a 3x to the 5th plus x. And then let's do one more. 6 arc tangent e to the 4x. So what's the derivative? So y prime, that is equals to the derivative of arcsine is 1 divided by, so we have 1 divided by the square root of 1 minus x squared. X is 3x to the 5th plus x. And then by chain rule, so by chain rule, you need to take the derivative of that. The derivative of 3x to the 5th is 15x to the 4th, and then plus 1. So this one you can draw an arrow and say this is by chain rule. So every time I use a big multiplication dot, I know that I am using chain rule. For arctangent is 1 divided by 1 plus x squared. So we have a 6 divided by 1 plus e to the 4x squared. And then what else? And then since there is a 4x squared inside the arctangent parenthesis, you have to use a chain rule to take the derivative of e to the 4x. E to the anything is e to the anything. And then the derivative of 4x is equals to 4. This one, if you want to make this to a more compact form, you can put the 15x plus 1 on top. And then this, you can square the 4x. So you have e to the 4x times e to the 4x. 4x plus 4x is 8x. And then 6 times 4, you can put a 24. E to the 4x on top of the fraction. All right, so moving on to number 2. Number 2, let's switch to a different color. So number 2, let's use orange. Number 2, we have f of x equals to arc cosine of tangent tan x, and then subtract cosine of arc cosine of arc cosine. I'll just do an x, arc cosine of x. Okay, so derivative f prime of x. So arc cosine, you have a -1, right? You have a -1 divided by the square root of 1 minus x squared. So 1 minus tangent tan x square. And then you take the derivative of tangent. So the derivative of tangent is what? Is secant square, right? So you have a secant square of tan x. No, tan x. The derivative of tan x is equals to tan. So this, you just use a chain rule. And then from tan x to tan, you use a chain rule as well. So that takes care of the arc cosine. And then the cosine, what's the derivative of cosine? The derivative of cosine is minus sign, right? So you have a subtract. So the subtraction comes from here. So minus the derivative of cosine is negative sine of arc sine cosine of x, and then you take the derivative of that using chain rule. The derivative of cosine is negative 1 divided by 1 minus x squared. And then you can definitely simplify this. So you can definitely change that to a plus. And then you can put the arc, you can put the sine on top of the negative 1. Oh, actually, you know what? There is a negative 1, right? So there is a negative 1. And then there are two minuses, so that becomes a plus, so that is still a big minus. So it's subtracting, you put the sine on top of the square root, and then for the first term, you can put the 10 secant square, change that to a minus 10, secant square above the square root. So that's how you put the answer in a more compact form. Moving on, let's use this screen. Number 3, we have g of x equals to e. Let's do an exponent. The exponent, let's put an arc cotangent. So arc cotangent. Inside the arc cotangent, let's spice this up. How about x to the 100 power minus 3x? What is the derivative? E to the anything is just e to the anything, right? So we have e to the everything. Cotangent x to the 100 minus 3x, and then by chain rule we take the derivative of arc cotangent. The derivative of arc cotangent is right over here, so that is negative 1 divided by 1 plus x squared. So you write a negative 1 divided by 1 plus x squared. So you have 1 plus what is x? X is everything inside the parenthesis, which is x to the 100 power minus 3x, and this is by chain rule, and then the chain continues. You also need to take the derivative of that, so using chain rule, so that is take the 100 down, x to the 99th power minus 3, and this is also by the chain rule. And then this, to simplify, you can move the negative 1 out, and then you put the e, and the last term the e, and then this parenthesis in the numerator to make the answer look more compact. All right, so moving on to the next problem. The next problem, I'm trying to do an arc sine. How about t of x equals to arc sine, and then we have x divided by 1 minus x. What's the derivative of arc sine? Inverse sine. What's the derivative? 1 over, look all the way to the top, 1 over square root 1 minus x squared. All right, so let's do that. So t prime of x, this is 1 over square root 1 minus x squared, right? So what is x? X is the fraction. X divided by 1 minus x, and then you use chain rule to take the derivative of that. So this is a chain rule, and then this is a fraction, then you have to use a quotient rule. What's the quotient rule? Quotient rule is fg minus fg divided by g squared, f first, g second. So you have to square the x1 minus x squared, f prime, the derivative of the numerator, and then times denominator minus the numerator times derivative of the denominator. This one, the top, so this one, the top is 1, right? Minus x, and then plus x, so the top is just equals to 1. So the top is just equals to 1. Right, you can just simplify the top. Okay, so I will call this the end of this video. If you like it, you think this is helpful, give me a like, share the video for me, so let the algorithm kick so more and more people can see my video. I will see you all in the next one. Signing out.